Yeah, hi everybody. It's great to be here, and thanks for letting me talk about the grammar of graphics in Python. It's going to be a talk about data visualization, and I will start with my motivation. So I'm not affiliated with any of the libraries that I will mention, but I'm an interested user with a passion for data visualization, and also quite interested in the history of data visualization. And what you can see there on the right side is one of the possibly oldest data visualization from a physician in London who basically was there during one of the cholera outbreaks, and during that time, the theory was that that cholera is spread airborne, and that it's kind of due to bad air. And he had the suspicion that it's basically something that is spreading via water, and so he plotted all the casualties in the map, and basically was kind of able to show that his hypothesis is right, because the casualties were very high around a certain well where the people took the water from. And I think it's sometimes great to see that what data visualization can do for you, and also to remind what we are taking for granted, how this kind of came into place. So now I work at Blue Yonder right now, and I'm mostly doing data engineering these days. So no plots for me anymore, no visualizations. I used to do that a bit more, and in an earlier life I prototyped, for example, grammar of graphics prototype for Haskell, and also I wrote a plotting library for Ruby almost 14 years ago. And one of the nicer things that happened when I wrote this library was that I one day got a package delivered to me by one of my users, and he sent me these 3 books and said, look at them, they are really really good if you're interested in data visualization. So I can only recommend these to everybody to read them. They have a lot of good examples. They also explain why they're good examples, best practices, what not to do with visualizations. And actually, there's another old visualization that is shown in there, which is quite famous, by Charles Minard, also from the 1860s, and he visualized Napoleon's campaign in Russia, and they're shown how basically the armies, the divisions, are decimated on the way to there, and there's also their retreat, and you can see like rivers that were crossed, and also for example you see the temperature and the days, and there's a lot of information shown in this graphic. And what I want to do today is actually recreate this graphic in Python, and doing that I want to use the grammar of graphics, which is a concept already around for a while. I think late 80s. This book came out in the 90s by Leland Wilkinson, describing a way to kind of structure visualizations, and he described the system Infosys. I think a lot of that went into becoming Tableau nowadays. And the idea is that that a grammar basically makes a language expressive, and this is a quote from the book, and that a language that has words and no grammar expresses only as many ideas as there are words. So the grammar basically restricting how you compose things, thereby actually making things more expressive. And I think that's a great concept to also go into visualizations, not having templates where you just fill things in, but actually being able to compose things to build something that is more than the individual parts. So the grammar of graphics basically is building blocks, how to build individual visualizations, but then also rules of composition, how to compose things together in a very structural way. So there are different parts for these building blocks to build a single visualization. So it describes how you transform data from your input data towards something that is then on the screen or printed or can be printed. And the first part that you often do also in data analysis are some transformations. You have aggregation, statistical transformations, conversions. And then the transformation to the kind of visual space comes. That's the mapping, or it's called aesthetics in the book. It's the mapping from the data to actual visual properties, and it's a difference of what is mapped or what visual properties represent which data. And then you have the second part of that, the scales that determine how is this mapped. So how is the transformation going? So how is data represented? Is it a color scale? Is it, I don't know, is it something that is a positional scale? And once you did all that, you can use the information that the scale determines to how to transform data to actually give some hints for the user to do the reverse mapping, because that's what the visualization is about. Actually, it should tell something about the data. So you need some guides, that could be a legend or axis, and they all basically give the user a hint how to reverse your mapping. So tell you, for example, this color stands for a specific value that it represents. So I'm going to give a quick rough example. So for example, we have some data here, and now we say we want to visualize this data or some of the data in a scatter plot. So we want to have a point marker, and basically we say the position X and Y should be represented by the columns A and C, and we have the shape that should be represented by the column D. And now the step of the aesthetics and the scales is basically, so you take this encoding, do you map it into this marker space and have to apply the scale. So suddenly your data now is in kind of like the spaces of your visual elements. And this is now a simple recipe that you can use to make a graphic. And now using the information to do the reverse transformation, you can put axis there or even a legend. And that's kind of very structural way how to build a plot that is a bit more in detail than just doing, say, like scatter plot or something. There are a lot of libraries that actually implement this. Possibly if you're used to R, you know ggplot, which follows this quite closely and even adds a bit more to the original concepts. For Python, there's now kind of triplet of libraries. The first two aren't even Python libraries, they're JavaScript libraries, but there's a Python interface for that. There's Altair, and it's an implementation of the grammar of graphics, but it also adds an interactive part, which wasn't there when the system was described in the kind of early parts. Just to give a little bit of structure to that, because at least I was quite confused when I looked at it initially, because it's 3 libraries. So Altair is written in Python. The input is in Python. You specify your plots in Python, but what you get as output is a JSON, which is a vega light plot, which then is fed to the JavaScript compiler for vega light, which then creates a vega JSON, which is then fed to vega, which can be rendered to SVG and Canvas. Luckily, that is all behind the scenes, so you don't see much of it, but it's always good to know. Also because there's a difference between these two JSONs. The vega light is a kind of high-level grammar. It's a bit less expressive, but way more concise, and we'll look at an example in the next slides. And Altair basically is the same specification, just partially even auto-translated from the JSON schema. So you have an API that follows quite closely, but allows you to create these JSONs in a very Pythonic way then. Vega, on the other hand, is low level, more expressive. You can use that if you reach like real hard boundaries, or if you want to kind of include these plots into your own web service or add some interactivity. You can stream data to it. So that's all part. I won't touch, but it's nice to know how this works together. Now I want to go actually look at it. I just took one of the examples from the website, from the documentation. This is you have a test data set. It's a car data set about cars. So car models, origin. You have the horsepower here, miles per gallon, and similar to the plot I showed before, like in the keynote example. Here we encode the position by 2 columns in the data set, and we encode the color by the origin, and so we get this plot and the scale, this color scale. We don't have to specify something, so that's something you usually get. You get a lot of kind of same defaults, but you can always change these if you want. So it's a very good way to work iteratively towards visualization. Now the JSON that we get out from Altair looks quite similar. You see there's some type information that Altair deduces automatically, but it's quite close to what you specified in Python. The nice thing about this is also that it's now fully serializable. You can send it somewhere. You can store it if you have a web service or something. It's easy to send there. That's kind of one of the nice things about the library. And now this one, probably you can't read it anymore. This is then what actually comes out of it for Vega. And there, some information is actually that the library automatically deduced for you is specified in an explicit way. So it says the x-axis is a linear transformation from the data, and it specifies that the domain says it's automatically all the values that are in this column, and it says the range, so it mapped to the full width of the plot in the kind of screen space. So all this theory about how to map values to the screen is encoded in there. Now that we have kind of the building blocks, we can compose them. You have similar building blocks for like bar chart, box plots, and you can have a lot of kind of basic visual representations that you can use. You can also compose these plots. For example, I have a base chart, the same I had before, and I also do some binning where I bin the x-axis and just take the mean value for the y-axis. And I have these 2 charts, and I now have different ways to compose them. For example, I can do a vertical concatenation, horizontal concatenation, or I can just layer them, so you can build up your plot in an easy way. And that's just combining these, and you get new objects that you can then combine again. That's kind of a nice way to build a full kind of chart, or even something close to a dashboard. There's also faceting, which is a typical thing you do. So you can here facet by origin as well, so that you get a plot for each value that you have in a column, and which is then giving different colors there. Or repetition. So faceting is also very easy. You just call the facet method on it, say which column you want to use, and basically you get this plot out of it. Repetition works by repeating the plot but using different columns per plot. This is a bit more complicated because you have to specify in your encoding what the x and what the y-axis are. Actually, you have to say here that you want to map it to the values that you use in the row and column, but still it's quite a compact way to kind of create these plots. Then if you compose these things, often nowadays people ask for interactivity. How can we use this in an interactive dashboard? There's even some widget support, but one of the basic stuff that you can do quite easily is adding selections. So again, having a plot where we have which consists of 2 parts, you can create a selection. And basically the selection can be used in conditions. So you can have conditional, for example, coloring for the selection. You specify which plot actually creates the selection, where can you move your mouse. And you can, for example, filter input data from a selection. And for example, here now I can select an interval, rectangle, and once it's selected, only the data points in there are colored because we specified that here. And on the other hand, we can filter it so that the bin plot only takes into account the data that is represented in the selection. And that is all in the plot. So once you have this JSON specification, it's loaded somewhere, there's no server needed to kind of send the data back and filter it. That's all kind of in the specification, which is also quite nice. So it's very self-contained there. So now let's start to recreate the plot I showed in the beginning. With the data set, and we heard yesterday, reads CSV is one of the most important functions, so we're using it here. And we have three basic data sets. One gives you the troops. It gives you longitude, latitude information, the number of survivors in the army, the direction, so the advance or retreat, and there were 3 divisions. You have also a data set about the temperatures. That was the plot or the part that you could see on the lower end. And there is also an information about the cities. So basically kind of to give a rough map, and, you can get all this, data. It's not very much, so it's not big data we're doing here. It's very, very, 1860 data. So the first try is to basically build a line chart, and something took me a while because I didn't find it in the Altair documentation, but it's actually in there. You can use a trail visualization, because if you use a line chart and you try to encode the size, it always needs to have like 2 points for each line, so start and end point. But if you have like different sizes for each point of time, the line looks really jagged, or parts are not displayed, and this trail is really the thing that you want to use there, because it gives you a kind of nice, it follows kind of the size. We also color the direction, but when we plot this here, we see, okay, this doesn't look at all where we want to go. Maybe we can roughly get a rough idea that this is that this is related to the data that we've seen, but I don't know. I wouldn't like to work with this. So the nice thing, what's not working here, longitude, latitude mapping just directly to screen coordinates is maybe not the right transformation to use. Also, we are not taking the divisions into account. There were like different branches that we need to have in here, even though they have the same color. So the next iteration is, and that's really nice about Altair and Vega, it has kind of inbuilt support for geodata. So you can just say anything where you have X and Y, you can say just longitude, latitude, and specify a projection. So we use a Mercator projection here. And we directly want the right coloring, so we define a color mapping between A and R. So we use the same colors as in the plot from the 19th century. And there's also a detail key, and that's kind of an additional group by. It says like that the visual elements should first group by division, so that each gets its individual trail, and there's no connection kind of when you end one, but there's an actual break, so you can add additional breaking points. And if we create this looks already quite much more close to what we've seen. So that's kind of the first step that we have, but there's still more. We can also do text marks. We use again longitude, latitude. We use some nice font that it looks like the original, and we just write the kind of the survivors in the army as text up there. It's a bit overlaid, but if we look at a larger plot, that's probably going to be solved later. So that's kind of the second component for this graph. Then we have the cities. Basically, it's the same. There's some kind of small thing in there with a dx. You can just do a constant offset argument, and that kind of offsets all the things that you're plotting, because I mean, I know what comes out in the end, and we need this little offset so that the texts don't overlay. So that's another part. So the next thing is, now we have all the parts for the upper plot. We want to also have the temperature chart. What I'm using here, I'm directly combining 2 charts. So I have the line the line that showed the temperature. I mark the text, so I have the label where it says the date and the temperature, and so we can have a look here. I'm not using a longitude and latitude anymore because it doesn't work mixed. So the y-axis is temperature, doesn't really work with a kind of with the longitude latitude data, and you can't choose just one axis to be that. But the nice thing is that in the Mercator projection, the longitude is just linear, so we just scale it to the right range. So now we have another component. And basically we are there to now combine them all, except the rivers that were in there. I tried to find the river data because Altair can also plot like GeoJSON, but it's really hard to find local GeoJSON for data for rivers and get them. So I didn't succeed there. Now we have all the plots, so all the basic building blocks, and we just layer for the map chart, layer all things together. We say that the height of the temperature chart should be 100 units, so that it's kind of like resembling what we used, and we disable the grid and set the same font for the label that is propagated to all axis labels, and do the vertical concatenation. And then what we get out there is a chart that maybe is not publication ready, but I feel for like maybe an hour of effort, this is already pretty close what used to be represented in this kind of chart from 1869. And that's a really nice way, I feel, to build up plots, and something that you can use in Jupyter Lab right out of the box. So there the workflow is really, really good. I on purpose didn't want to make a feature chart comparison with Plotly, Bouquet, Matplotlib. You probably have to kind of find out yourself what fits your use case best, because they all target a bit different use cases. But in the end, I think the Altair has quite a high entrance barrier because of this kind of building blocks you first have to build. So it's not just a single function, but you have to kind of get into the concept. But once you know them, you can actually see if that fits your use case and if you want to use it. And yeah, that's basically it. Thanks for listening. Also, we're hiring. If you're interested, we have a booth out there. And yeah.
Questions, you can raise your hand and we can have a couple of questions. Yep.
Hi, thank you for your talk. Did you publish your code somewhere so we can recreate your chart?
I haven't published it, but I will.
Any more questions? Anybody? Yep.
Great talk, Malte. Thank you very much. I got a lot of insights. I'm from the R community, where I'm aware of the package ggplot2. Now, you have now just proven that everything that we do in ggplot2 also works in Python. I'm wondering, did you this first graph that you showed with the historical visualization? I didn't really get how basically the soldiers were crossing over the river somehow, or what?
The historical? Or?
Yes, the historical one. What was the black line and the yellow line again?
So one was the advance.
Okay.
And the other one, the retreat of the army. So when they moved back. So it's always like one division going and then reaching Moscow and then basically retreating and getting back.
Now I see.
Yeah.
Thank you very much. Okay.
Thanks. I love that info chart from 1854, and you've done a great job in showing that you can actually kind of programmatically recreate it. I'm curious about the streaming aspect that you mentioned. So if I want to display dynamic data, can you say a few words to that?
So Vega has a mechanism to kind of, so everything in there is a kind of graph, like a scene graph that takes in streams and plots that to the canvas or SVG chart, and it can kind of input change sets, and that's an API you can use, but it's something that from the Python side, from Altair, isn't directly supported. So it's based on the using like CSVs or directly encoding the data in JSON. But if you have some JavaScript part where you can push the data in there, you can also use that to kind of actively change the data set for a plot that you created with Altair, for example. But it's not, for example, if you want to have something there with a low entrance barrier, probably Bouquet is something where you can push the data much more easily from Python into your plot.
Thank you. Questions?
Thank you for the great talk. I tried Altair some time ago, and do you have any, or can you say where Altair has its limitations? So when you won't use Altair for visualizations?
So one part, if you want to have quick widgets or interactivity, I think Bouquet has still a lower entrance barrier, while it's I think Altair or Vega itself is catching a bit up with also adding widgets there. I also found it quite hard to get something publication ready out of it, because you have the SVG and you can render it, or if you want to render it even to SVG and not to JSON from Python, it's you always have to install Selenium and the Chrome driver, and all that feels a bit kind of hard to as a kind of automatic workflow, for example. But for stuff where I use, for example, Matplotlib, it now replaced it completely for me.
Thank you.
Any more questions? Yep.
Is there any way to do 3D plots with Grammar of Graphics or Altair yet?
As far as I know, they currently only support the two-dimensional coordinate system or like the map projections, but I think even with polar plots, it's already a bit, the support is a bit lacking right now.
Yep. So, there's one question there. Okay.
You had this, I think it was Vega.
Yeah.
Vega Lite. So can you show the Vega Lite specification thingy? Yes. No, the Vega.
Yeah.
And then you zoomed in?
Yeah.
So what happens if I set nice to false?
I actually don't know. Probably it's not that nice anymore, but.
So, anybody still have a question? I think we can have one or two more questions, and then we can have lunchtime. Yeah.
I have a hint, and I stumbled over that, and it took a while. Don't run Altair on Python 3.5.2. That has a bug which breaks Altair.
Okay.
So you have to at least, if you use 3.5, you have to at least use point release 3.
Good to know.
Xenial comes with 3.5.2. So use account Ubuntu or use Debian Stretch.
Yeah. Okay, last question. Thank you.
Just a hint, because I've read the book and there's a chapter in it about this nice thing. It's actually about which numbers are displayed on the axis, because if you just use linear interpolation, you get things like 3.843, and what you have here is 40, 80, 120, which is really nice to read, and I suspect that this is the nice value there.
Makes sense. Thanks.
Okay, thank you very much. So I think now is the time for lunch, and then let's give Malte a round of applause. Thank you very much.